Hi everyone, this is the Math Man here today, talking to you about the 5 different types of relations that we need to know. We're going to use the analogy of travel or transportation to try and remember and understand the way these functions work. So the first relation we have is called the direct variation relation. Direct variation says you have to multiply the x by a number to get the y. In this case, we're going to talk about the cost of driving a car. If you travel 0 kilometers, it costs you nothing. And if you travel farther, then it's going to cost you more for the farther you travel. The distance would be measured along the x-axis, and the cost would be on the y. And what this means is the farther you travel, the more you have to pay. Let's put a car in there just to get the idea of what's going on and an image that you can follow. The equation for a direct variation relation is y equals ax. And the idea is you can calculate the y, which is the cost, based on the distance you travel, which is x, times the price of gas, which would be the a value. Nice to travel in your car. Sometimes you need to take a cab. Well, the way it works with a cab is a little bit different because the moment you get into a cab, you have to pay an initial amount. So this is no longer going to be a direct variation relation. When there's an initial amount, it's going to be a partial variation relation. And like I said, we're going to use the idea of riding in a taxi cab. When you get into the cab, they charge you an initial amount. And so that would be shown on the y-axis, and that's the price you pay when you get into the vehicle. And then you still get charged the distance according to the distance that you travel. And so this would be a partial variation relation, y equals ax plus b. B is the initial cost of getting into the vehicle, and a is the price per kilometer multiplied by x, which is the distance that you travel. Traveling in a cab is nice and comfortable, but not that economical and definitely not as good for the environment, which leads us to our third type of relation, which is the zero variation relation. Now, a zero variation relation is going to be less complicated, but sometimes more confusing because the zero variation relation has what we say zero variation. The graph is going to be a horizontal line, and that horizontal line represents the same cost regardless of how far you would travel along a certain distance. And what are we talking about now? Driving on a city bus, right? You're going along there and it costs you the same amount no matter how far you travel. And the cost is based only on the price of getting on the bus. So y equals b, b is the initial value, and that tells you how much you're going to be paying for your entire trip regardless of how far you go. So that works for those 3 linear equations and relations in that each of those equations was a line. Now we get to something a little more complicated, and that's the idea of an inverse variation. Now, an inverse variation is based on the idea of a division or a sharing or a splitting up of the x values. So an inverse variation, the best description I can think of is renting a bus to go to New York, let's say, and you're going to bring a bunch of friends because taking a whole bus for just one person is not that worthwhile. And so instead of worrying about the distance that you're going to travel, this time we're going to talk about the number of people that go with you. And the way it works is the more people that you have on this trip, the less it's going to cost you for the rental of the bus. So in other words, it's going to be a very high cost if you have a few of people, and the price is going to diminish quickly the more people you have to split the fare with. And this is, as I said, an inverse variation relation, and the calculation is a division. You divide the total cost of renting the bus by the number of people that are riding with you. And it's an inverse variation. Reminder, it is not a line, it doesn't cross the axis, and it's decreasing. In other words, the more people you have, the less cost you have to pay. And the last function or relation we need to talk about is the squared variation relation. The squared variation relation doesn't really relate people or cost, and so we have to scrap this concept just a little bit. And we're going to take a little bit of a imaginary stroll here to an idea of a free-falling body. And let's stick with the idea of transportation, a car driving off a cliff. Now, this is called the squared variation relation, and the important thing to realize, yes, it's not linear, and when we put the values on the x and the y-axis, the amount on the x-axis will be measured in time, and the vertical axis would be the height or the distance measured vertically. Now, the reason I have to use either height or vertical distance is that here the height is decreasing, and yet when we talk about a squared variation relation, generally we talk about an increasing amount where we talk about the vertical distance that something would have traveled. So even though we have this idea of a car falling down, the graph for this is going to be an uphill um, graph, which is related to the idea that the car is speeding up, and so the height or the distance traveled vertically increases rapidly. And it goes faster until it reaches terminal velocity, but we won't get to that. So the car travels over the cliff, and we have the idea of increased distance depending on the time that it travels. So hopefully those 5 types will give you a clear understanding of what you need to know, and you can practice some examples on this. Thanks. Have a good day.